So I wanted to go over the L'Hopital's rule just to ensure that we are doing proper form for the test, if and when you use it. So the graph of the function f is shown below, so this is the position function, okay? And you're going to determine the value of this limit. So you are approaching 2 means as you approach positive 2, what is the values that you're going to be getting from this limit? So if I put 2 in here, I get a value of, if I approach x is 2, that is, I would get, in this function right here, 2 minus 2. This is direct substitution right off the bat. Now, if I looked at this, and x is 2, and it's approaching 2, then this is 3 times 2, which would be, what is f of 6? So my mistake on that, you're not approaching 2, you're actually approaching 6. So f of 6 would say, what is the y value at 6? Which gives you a negative, what? Negative 1. So negative 1 times this 2, like a coefficient would give me a negative 2. Negative 2 plus 2 would give me a 0. So I have a 0 over 0 indeterminate form. Right off the bat, do not on the test, if and when you use this, do not say that this is equal to 0 over 0. Because what you just did there is now you cannot use L'Hopital's rule. Because you're not saying that this limit is equal to 0 over 0 because it's not. 0 over 0 is an indeterminate form that we don't really know, that we don't really say is equal to whatever the value of the limit is. So we will identify. You can mention off to the side that you have a 0 over 0 indeterminate form. And then from here, you're going to break it up and do the work. Okay, so the very first thing that you're going to do is that you're going to state that each function individually is continuous. Okay, so you'll say, let's say that f of x is the top function. So f of x is equal to 2 minus x is continuous. That means it doesn't have any holes or gaps, removable discontinuities. There's no pieces that are dividing by 0 that would undefine out. In other words, like you don't have a graph that's like 1 over x, where you could have a place where it wasn't continuous at 0. The bottom function, you could say, is g of x. Okay, so you could say g of x is equal to this 2 f of 3 of x. Okay, and then it's like plus 2. You could say this is continuous. Okay, so now that I'm looking at this a little bit more, the way we're assigning, I'm glad it just happened. Because of the fact that we have this right here is representing the graph, we don't necessarily want to put this as f because they're 2 totally different functions. So as long as we name it anything, it could be any other function. We could even say h of x. We're just mentioning that each independent piece is continuous. Okay? Then you're going to also say that the next part is the limit as x approaches 2 of this established h of x is 0. And yes, you could have written 2 minus x if you wanted to all over again instead of h of x. But the way I'm assigning it to a certain function, then I can kind of shortcut by just putting h of x here. Okay. So then I have, the next one is the limit as x approaches 2 now of this g of x is also equal to 0. I know it's a lot of annoying work, but all we really just verified were that we have 2 continuous functions on top of each other that have a 0 over 0 indeterminate form. And now we're going to keep going using L'Hopital's rule. So we'll say using L'Hopital's rule, we should have said this at the very, very beginning. Let's say that after you mention that it's indeterminate form, put the using L'Hopital's rule there, the second piece right here, and then go on to do all this. Okay? So I'm running a little bit out of room. Let me write it up here at the top. We're going to now do the derivative of the top and the bottom. So what's the derivative of the top piece? Negative 1. So the derivative of the top piece is now this, and then what is the derivative of the bottom piece? So like let's look at this 2. What's the derivative of that 2? 0. And so now I'm looking at this. Yep, so it's the f prime of 3x. So it's like chain rule, if you will, right? It's the derivative of the outside, carbon copy, and then you're going to multiply by the derivative of the inside, which is just 3. And then this constant multiple rule, you're just going to multiply the 2 in to where it becomes 6 f prime of 3x. This will be down here. It is still going to be the limit as you approach 2. And now you're just going to plug them in again. Okay? So now from here, this is after you've taken the derivative, you're going to plug in 2 to get what is f prime at 6. So the f prime at 6 is right here. What is the slope that it's creating? What creates an up 2 over 1, right? So then the slope would be 2 multiplied with the 6 would give you 12. So the answer would be a negative 1/12. So just recap. You're going to not set it equal to 0 over 0. You're just going to mention this indeterminate form. Then say, using L'Hopital's rule, assign the top function to something that you're saying is continuous, the bottom function to something that you're saying is continuous, individually solve their limits and show that it is in fact a 0 over 0, because the other form that's indeterminate is infinity over infinity. So either way, both of them will work, okay? And then after that, we'll come up here and write out the derivatives as a fraction, and then just plug and see if you get an answer. What if, that's all one iteration, okay? What if here I got another 0 over 0? What would I do? I would do it all over again. If I get another 0 over 0 indeterminate form, it's like I have to do all of this one more time. Okay? You would mention that you have the indeterminate form, that you have the L'Hopital's rule, but this time when you establish a new function, you would just put negative 1. When you establish a new bottom, you would just put the new bottom. And then still derive at the next piece and do it again. Basically, you would do all that work one more time. Okay? Or many times until you get an answer that's either a quantitative answer, or you might get something that will give you an infinity, like a negative or a positive infinity. Or you might even get something that will give you a 0. Or last but not least, you might get something that doesn't exist. Like if it was 28 over 0, that would be does not exist. If it was 0 over 28, it would be 0. You see what I'm saying? And infinity could look like something like, if you're approaching infinity, you could have like, let's say, x over 3. So when you plugged it in, infinity over 3 would equal infinity. Cool? All right. So again, this is if and only if the indeterminate forms of 0 over 0 or infinity over infinity pop up, and you have to use it. If they don't pop up, you never have to use L'Hopital's rule. Use like the methods that we learned at the beginning of the school year, the easier ones. You know what I mean?